Hello, Professor. This is my presentation of topic 8, DQ1. Now I share my screen so I can explain my codes. I share my screen now, share. And what I have here is the data set. And the data set is related to the health insurance charges, which includes several features like age, sex, BMI, children, smoker, and region. And an example here shows this is the visual, shows a scatter plot that shows a positive relationship between age and insurance charges. Now, another type is a heat map, and this heat map shows age, BMI, children, and charges. This is the correlation heat map. And let's look at one example here. For age, it shows that the effect of age on insurance charges, that the coefficient, the correlation coefficient is 0.3, which suggests that there's a moderate positive relationship between age and insurance charges. Now, exploring the possible research question, the first would be exploring the dataset through EDA. And the first research question that I have here is about the effect of age on insurance charges. And the research question is there a significant correlation between person's age and their insurance charges? And the hypothesis is younger individuals may have lower insurance charges compared to older individuals. And this is the box plot that I did. No, this one is the, sorry, this is the heat map and the scatter plot that I did for that. And that's the visual here. One visual, and this one shows here too, charges against age. And the insights from this is that a person's age and their insurance charges are statistically significant. That is when I did the person correlation coefficient, and I got these values here. It shows that the hypothesis could be rejected. That is, individuals getting older, their insurance charges tend to increase. And this finding is aligned with the hypothesis that younger individuals may have lower insurance charges compared to older individuals. The other research question could be about the impact of smoking on insurance costs, where the question is, are smokers higher insurance premiums than non-smokers? And the hypothesis is insurance charges for smokers are expected to be higher due to increased health risk. And this is a visual here showing the box plot of smokers against non-smokers. And these here is from the t-test results, and the p-value. And the t-test is highly significant with a very low p-value, which indicates strong evidence against the null hypothesis, suggesting that there is a significant difference in insurance charges between smokers and non-smokers. The null hypothesis is rejected in this case, and this supports the hypothesis that insurance charges for smokers are expected to be higher due to increased health risk. Another research question here that I looked at is BMI and insurance cost relationship. And the hypothesis is individuals with higher BMI might incur higher medical expenses, leading to increased insurance charges. And this is a scatter plot that I show here. And here I did the correlation, person correlation I did here. And the insights from these results show that the p-value is extremely small, providing strong evidence against the null hypothesis. And this suggests that the observed correlation between BMI and insurance charges is statistically significant. And this supports the hypothesis that individuals with higher BMI may incur higher medical expenses, leading to increased insurance charges. And this is the overview here of how I would approach the analysis using Python. And these are the steps that I have here of the approaches that I will use. First, I will load the data set. After I load the data set, here, I will do the EDA that involves displaying the first few rows of the data set, then do the summary statistics, examine and inspect for missing values, examine the data and look for missing values. In this case, there are no missing values. This is followed by the visual to show the relationship, which is the scatter plot, heat plot, and box plot. And the hypothesis testing is performed. Then there's the interpretation of the results. That's just below every value here that I have. That is, I have the reporting. And that is my presentation. Now I stop sharing the screen. And thank you. That's my presentation.